Okay, so we're going to go through another example of grad, and this time we'll perhaps start with phi equals x squared, y squared, z squared. The first thing we'll do is we'll just try and find grad of phi, which is also written as perhaps nabla phi. So we will have so many i's plus so many j's plus so many k's. To find out how many i's we have, we simply partially differentiate phi with respect to x to get 2x y squared z squared. That should be squared there. Differentiate j, so we differentiate phi to find we have x squared 2y z squared, and then finally to find the coefficients of k we differentiate phi with respect to z. So we get x squared y squared 2z. That's it, we found grad of phi. Okay. What else would we like to do? Perhaps we might like to find grad at a particular point. So if we look at the point minus 1, 1, 1, all we're really saying now is what is the grad of phi when x is minus 1, y is 1 and z is 1. So at a particular point can we find the grad? And all we do is replace the x, y's and z's with minus 1, 1 and 1. So our solution to part A will become minus 2i plus 2j plus 2k, simply by replacing all the x, y's and z's with the appropriate values. So we find we still keep the minus 2 here for the I because we had a x term here, but later on we had x squareds there, so of course minus 1 squared is a positive 1. Okay, so that's our solution for B. Part C might be perhaps to find a unit vector in direction of this. By this I mean the solution to B, the grad of phi at minus 1, 1, 1. So how do we find a unit vector? Well, to find a unit vector we need to find the modulus of the vector, and then we simply divide by that. And we find the modulus by using Pythag. So we're going to have minus 2 squared plus 2 squared plus 2 squared, which will give us root 12. So our solution, a unit vector in the direction of the answer to part B, would be 1 over root 12 minus 2i plus 2j plus 2k, and that would be our solution. I think in this particular case we can tidy it up a little bit. For example, there's a common factor of 2 in the brackets, and root 12 would simplify, so we could rewrite this as 1 over 2 root 3 for root 1 over root 12. Bring the 2 outside, and minus I plus j plus k, which we could rewrite as 1 over root 3 minus I plus j plus k.